Hello everybody, in this video I'll be demonstrating DHCP for IP version 4 and source NAT, also known as PAT, port address translation. So the setup here is quite simple. This BR2 stands for branch 2. It's assuming this is our router that goes to the internet. This link here, which is fast Ethernet 1/1, connects out to the internet, which is represented by this cloud device. It's just a simple router. You can ignore this diagram on the left. I'm going to be using it later to demonstrate IPsec connection between the two branches. But for this part of the lesson, I'm going to be setting up a private IP on this link, which is gigabit 0/0, and I'm going to get PC2 to obtain its IP address via DHCP, and its gateway will be this router, and then this router must take this 172.16.0. whatever address this PC gets assigned and translate it into this WAN address as the source address when the packet goes out. That is known as network address translation. The reason why you do that is due to the limited amount of IP version 4 addresses available. So the range 172.16.0.0 up to 172.31.255.255. That's actually the Class B private range which we're going to be using. There's other private ranges as well that you can use if you're going to be doing this NAT. 192.168, that's a very common one, used mostly in people's homes. And then the other one you'll see is starting with the 10. If you're studying, you might need to know that the one that starts with the 10 is your Class A private range. The one that starts with 192.168, that's your Class C private range, and the one that starts with 172.16 up to 172.31, that's your Class B private range. But anyway, just to get on with it, let me do the configuration for you. So we start by going into global configuration. I previously did a show IP interface brief here, and here you can see our interfaces. This gigabit Ethernet 0/0, that's the one that goes down to PC2. So that's where we're going to put our LAN IP, which is IP address 172.16.0.254 with a 24-bit subnet mask. And I forgot to actually go in the interface, no problem. Do that quickly. Put the address in. Type no shutdown. So that's the address on the LAN. Now I'm going to quickly set up a DHCP. So first thing we're going to do is exclude the addresses we don't want handed out. So go IP DHCP excluded address, and I'm not going to hand out any of these. So anything from 172.16.0 to 250, 251, 252, 253, 254 will not be part of the addresses we'll be handing out. And we can also do this with another set of excluded addresses. Maybe we want to get some from the bottom that we don't want to hand out. So we can go, let's say, from 1 up to 72.16.0.49. That means the first address we'll hand out would be, let's say, 172.16.0.50, because 1 up to 49 we're not handing out, and 250 to 254 we're not handing out. So now to set up the DHCP pool, it's IP DHCP pool. You give it a name. I'm just going to call this one VLAN 1 because that's the default VLAN on the switches, and I'm not going to set up any VLANs on the switch, so everything's going to be part of VLAN 1. So IP DHCP pool VLAN 1, gave it the name, and here I'm going to type the default router address, which is the LAN IP of this router, and we set that at the top here, 172.16.0.254. So this is the IP address that will be given to our PC as the default gateway. This is part of the network 172.16.0.0, welcome host 255.255.255.0. We specify the DNS server that we're handing out, 8.8.8.8. That's one of Google's, and we can hand out a second one as well. It's also one of Google's. DNS servers, if you don't know, translates a name like www.google.com into a public IP address, so that the user can type something easy for them to remember, but the computer at the end of the day needs an IP address to actually reach something. So DNS translates from a name to an IP address. Okay, and that's all you really have to do there to set up the DHCP. So you can type here do write, and that's just going to write your configuration file to NVRAM, so that if you restart the router, its config's not missing. So now here by the client already, if you type IP DHCP, well, wouldn't do this in real life, but this is how it's done in GNS3 with this client, the one that you get from here. No, sorry, not from there. Yeah, there. VP Virtual PC, I think that's what it stands for. VPCS, yeah. So in order to get it to get an IP, you type IP DHCP. And it sends a discover, gets an offer, and request acknowledgement. That's what that stands for. And you see, we got the address 172.16.0.50, and our gateway is 172.16.0.254. So we can just see if we can ping our router so long. Ping 172.16.0.254. Okay, that's working. Back to our router. Now the second thing we're going to do here is to set up NAT. But if I do a show IP interface brief, you'll see the only IP we've defined so far is this one on the LAN. There is nothing else here. This link here is fast Ethernet 1/1, and on the other side it connects to this supposed internet router. So I just want to show you what's going on here. Show IP interface brief. And you see this fast Ethernet 1/1 on the other side, the IP address is 200.100.50.5. So the network that we're actually using here is 200.100.50.4, and it's a /30. That's that subnet mask 255.255.255.254, which is going to give you 4 IPs, but only 2 usable IPs. So your 2 usable IPs is 200.100.50.5, which is this one, and on the other side of the link we can have 200.100.50.6. So this side of the link is 200.100.50.5. So now we come to this router here, and we want to set the other side of the link. So we can go here, interface, fast Ethernet 1/1, with the IP address of 200.100.50. The other side was 5, so this side's going to be 6. 255, 255, 255.252. You say no shut to bring the interface up, and now that the interface is up, we can do a ping. You put a do in front of the word ping if you're going to do it from inside global configuration. You're pinging to 200.100.50.5. Okay, so that's this 200.100.50.5 is the first hop on our way to the internet. So now, if that was really going to be our internet connection, what we would have to do is we need a route, what they call a default route, meaning if you don't have a different route, use this one. So you always use a default route to go out to the internet. So you say IP route 0.0.0.0, meaning to any IP with that basically means to any IP. If the packet, doesn't matter what IP it's destined to, if you don't already have a more specific route in your routing table, then use this route, and those packets must be forwarded to 200.100.50.5. So that's our default route that will get packets to our so-called internet. Now I have set up 8.8.8.8 as a loop back here on this internet router. I can show you here. We can ping it. We can go do ping 8.8.8.8, and as you can see we can ping it. Why can we ping it? Well, go to show IP route. We have a route that goes there. There's our default route that goes, says if you don't know where to send it to 200.100.50.5. As you can see, we don't have a route for 8.8.8, so this packet will from here be sent to internet, that router there. Now you say, okay, does this router know the way back? Well, of course he does. He has when this ping goes out, it will be sourced from this IP address. Just give me a second. Let me just do it again. Show IP interface brief. So the ping when it goes out is sourced from 200.100.50.6. Right? The next hop is 200.100.50.5. So this router that's called internet, it knows how to reply to that because it has an interface on this network, which is the network 200.100.50.4, which has the two IPs 50.5 and 50.6. So this router can talk back. However, if we come down here to PC2 and we do a ping to 8.8.8.8, as you can see, nothing happens. And the reason for this is this PC has a gateway that is 172.16.0.254. So when it tries to ping 8.8.8.8, the packet goes to this router because it's going to forward it to its gateway, so it goes to BO2. BO2 has again a default gateway that sends it to internet. But now when it's sitting on this, the packet's on this router and the reply needs to come back, here's where the problem comes in. This router does not have a route to get back to 172. You see, if we go to this router, the only thing it knows about, because I haven't put any routes on it, is its own interfaces. So show IP route, you see it's got no default route, there's no 0.0.0.0, plus it doesn't have a 172.16.0 anything. So this internet router cannot speak back to this computer, which is pretty similar to how it would be in real life, because in real life your 172 IP, which you've got here, is a private IP, and your private IPs aren't routable on the internet, meaning somebody from the internet is not going to be able to talk back to your IP here on PC2 because it's an IP that is not reachable from the internet. So it needs to be translated before it goes out. So the packet's going to go out having, when it starts from PC2, being as a source packet from 172.16.0.254, but we need BR2 to exchange the source address to be 200.100.50.6, to swap it out. And then because this 200.100.50.6 is reachable from internet, the reply will be able to come back. So that is called network address translation, and I'm going to show you quickly how to set it up. First we go into fast Ethernet 1/1, that's our WAN interface, and we set that to be our NAT outside interface. It's IP NAT outside. There's another way of doing this as well, just so you know, where you use IP NAT enable, but for this example I'm using the more well-known, slightly older method. Okay, so interface fast Ethernet 1/1. If you don't know, that's this interface here that goes out to the internet. You say that's IP NAT outside. Then, okay, I'm just waiting for this router to get with it. It's a bit slow, or should I say my PC is a bit slow, seeing it's a virtual router. Then we go to interface the side that comes to the LAN, which is this other interface. This is inside our network, so we need to tell the router that. Interface gigabit 0/0 IP NAT inside. Then we need an access list, and the access list is going to select all traffic that should be NATed, meaning if this traffic fits the access list, then its source address must be swapped out for 200.100.50.6. Okay, so the access list is quite simple. You just say access list 1, access list, give it a number, call it 1, permit, and it must permit anything that's from the 172.16.0.0 network. Now, here I'm just going to press the question mark. With these access lists, you need a wildcard mask, which the way they're calculated is you take 255.255.255.255, right? And then you subtract from that your subnet mask, which is 255.255.255.0. And you're going to end up with something that looks like this. The easy way to remember it is where you usually have 255s, you now got zeros, and where you usually had a 0, you now got a 255. Okay. So that is the access list that's going to select the traffic that should be NATed. So here's the command that does the work. It says ipnat. It says I want to NAT ipnat inside source. So for the traffic that's coming, that should be NATed, the inside source should be identified by a list. That list is this access list we created. Its number is 1. And then we want that sent out of interface. The interface for the outside we said was fast Ethernet 1/1. And now we're going to put overload here. Now what overload is doing is it's going to allow us, if we don't use overload, then we need to actually use a pool of public addresses. So we need a public address for every private address. If we use the word overload at the end here, it's saying the same outside address can be used by multiple inside addresses. We're just going to use a different source port in the packet each time. So the first packet, could be coming from, if you had more than one person on your network, the first packet can be from 172.16.0.50, the next one from 172.16.0.51, and the next person that's trying to access the network 172.16.0.52. All of those source IPs in the packet that goes out to the internet will be replaced with this address 200.100.50.6. So all packets will have the same source IP address when they go out to the internet. However, when the device on the internet communicates back with us, the packet's going to be destined for 200.100.50.6. This router BR2 needs a way to now separate that traffic to send the replies back to the original PC that requested this information. And the way it's going to keep track of which device is using which IP is by using a different source port for each client that communicates on the network. So here's this command. It's ipnat inside source. So the inside source traffic must be anything that's identified by the list access list 1, and that's going to be NATed out of this interface or replaced with the address on interface fast Ethernet 1/1, and we want to overload, which I just explained how that works. So that's done that, so we're going to write that setting. So now the main command that can show us what's going on here is show IP NAT translations. As you can see, there are none. However, to show you what NAT does, have a look here. We go show IP. Our IP address is 172.16.0.50. If we ping 8.8.8.8, as you can see, it now works. But why is it working? Well, if we go to BR2, we do that same command and press the up arrow, show IP NAT translations. This IP address, which is called inside local 172.16.0.50, was substituted in the source IP of the packet for 200.100.50.6 when it went out to the outside global address of 8.8.8. Now this router here knows how to talk back to 200.100.50.6. It does not see a packet coming, this internet router does not see a packet coming from 172.16.0.50 because that source address in the packet was translated to 200.100.50.6 when the packet went out to the internet. So this router called internet has a route back to 200.100.50.6 because it's part, it's part of its interface. And then when the packet gets back to this router translates it back to destined for 172.16.0.50. Just to show you, we can use, I'm going to right click here, let me do Wireshark. Just need to minimize Wireshark so it fits in my recording screen. There it is. Just give me a second, let me bring up this PC2, bring that there, put Wireshark there. Alright, so Wireshark is checking the traffic as it goes out the router towards that internet cloud. And you saw earlier, if I go show IP, my IP address is 172.16.0.50. If I ping 8.8.8.8, look what happens on Wireshark. There come the pings. I'm just going to pause it a second. I'm just going to type ICMP in the top here so I only see the ping traffic. So the traffic that, well, my address is 172.16.0.254. Is there any traffic sourced from there? No, there isn't, because it has been network address translated. But here we have a packet. The packet is coming from a source of 200.100.50.6, which is the WAN interface on the router, and it's being, the ping is going to 8.8.8.8, and then 8.8.8.8 replies back to the router 200.100.50.6. Okay. Quit without saving now. Just going to stop that capture and start a capture here. Start capture. And let's do this ping again. So now we're capturing the information coming out of the LAN interface on our router, on our network. And if we do the ping again, let's pause this ping. Oh, sorry, I stopped it. Type ICMP just to show the ICMP. Now we see that the source is 172.16.0.50. That's our source, and we're pinging 8.8.8.8, and 8.8.8 replies back to us. So from inside the LAN portion of the network, it looks normal how you would expect it. But as you saw just now from the WAN side, this 172 IP gets translated to a 200.100.50.6 IP when it goes out. Anyway, that is my video on DHCP and network address translation, specifically source NAT, also known as PAT, port address translation. I hope you enjoyed the video, and I hope you learned something. Thank you very much for watching. Have a nice day.